If you look at the service edge deployment, the users connect to the service edge inside your data center and have the same policy applied. With a physical service edge, it is pre-configured with IP addresses and shipped to customers to deploy in their environment. Customers have no access to the operating system, no access to the device. It is a black box, and we provide them with redundant configurations and high availability for high throughput. With a virtual service edge, you can deploy it within your ESXi environment. Users can then forward traffic to the virtual service edge or the public data centers for the Zero Trust Exchange, meaning the policies are congruent across the different environments. You may also make decisions to deploy virtual service edge in AWS, Azure, or Google Cloud Platform. This means that you can provide the security policy for your applications and workloads running there, or extend your capabilities so that you have a point of presence in these cloud platforms where Zscaler may not be present. For example, in China, this may help you meet corporate objectives like a cloud-first strategy. So the physical service edge comes in two different modes, a physical service edge 3 or a physical service edge 5. 3 and 5 dictating the number of instances of the Zscaler enforcement node, now known as ZIA public or private service edge, within that service edge. So with the service edge 3, there are 3 ZIA public or private service edge instances and 1 instance of the load balancer. This is generally sized for about 1 gigabit per second internet link. You would always deploy these in pairs. So you would actually end up with 6 instances and the load balancers run active-active. And we will load balance across all 6 instances to give you higher throughput and capacity. The Service Edge 5 has 5 instances of the ZIA public or private service edge running within it, and 1 instance of the load balancer. Again, you would deploy the physical service edge 5 in pairs, meaning that the load balancer load balances over 10 instances. And because of this, these devices have 10 gig interfaces to give higher throughput capabilities. More instances can be deployed. More physical service edges can be deployed to give greater throughput capabilities. Within the virtual service edge, there is a physical interface, there's a load balancer, and the service edge instance. There is a management interface that you can use to SSH onto and configure options within the service edge. There is a load balancer and a service edge instance that's intercepting traffic and applying traffic. With the virtual service edge, there's only ever going to have outbound connectivity to the internet, and it'll download policy from the Zscaler Zero Trust Exchange to the service edge to apply policy. So there is a service edge instance, there's a load balancer instance, and then there's a virtual IP address instance for the load balancer that exists when you deploy multiple service edge. There is a management IP address deployed on each service edge instance to enable you to SSH onto it, to be able to then run diagnostics commands and configure the instances themselves. There are a number of different hypervisors supported and minimum requirements for the amount of memory. There's a maximum number of virtual machines within a cluster, so I can scale this up to 16 virtual machines in a cluster. We'd recommend that there's a SSL accelerator card within the physical hardware that's dedicated to the virtual machines to enable those TLS inspection offloads for those high-order operations necessary for SSL inspection. So, with a high-throughput private service edge, we can get 600 megabits per second for full SSL inspection. 2 different deployment mechanisms. We can go single arm, meaning the user connects through to the virtual IP. The IP hits the load balancer, so one of those load balancer instances will be targeted for that VIP, and the load balancer will load balance across those 2 service edges, and whichever service edge is chosen makes the outbound connection to the internet, and then we use direct server return to return the traffic to the client IP address. Direct server return means that the return traffic from the service edge doesn't pass through the load balancer or the VIP to get back to the user. So a single-arm deployment is applicable to both the physical and virtual service edges. We do have capabilities for a dual-arm deployment, meaning there's a separate IP address for internal and external traffic. So in this case, it's only applicable to the virtual service edge. The user again connects through the virtual IP address to the load balancer. The load balancer load balances across those service edge instances, and a separate IP address is then used to egress to the internet with a separate routing instance to get outwards. Again, direct server return is used to return traffic back to the user. So if we look at the deployment options, I would recommend you build a table out with all of the IP addresses that you're going to use. For each service edge in a cluster, you define the management IP, the proxy IP, the load balancer IP, and then the virtual IP that exists between those load balancer instances. We'll come into the administration console, the Zscaler Internet Access, now known as ZIA Admin Portal. We'll select Virtual Service Edges. We will go into the Virtual Service Edge configuration and set each of those IP addresses on those virtual service edges. Once the virtual service edge is then deployed, we download the certificate from the administration interface and load that certificate onto the virtual service edge instance, and that virtual service edge will then connect to the Zero Trust Exchange and provision itself as a service edge. Once you've deployed the virtual service edge, or the physical service edge, for Zscaler Internet Access, you need to make a policy to connect users to the service edge. Now, the service edge is a scalar instance. It's exactly the same as any other instance in the Zscaler cloud. So, making a policy decision for the Zscaler client connector comes down to what you write in your pack file in the application pack. In this example, we are able to look at a variable created on the pack file server for Zscaler called source IP. The $source IP variable will be completed by the pack file server when the user requests the pack file. So it's what IP address did the pack file server see the request coming from? And I can then write a policy that says if that IP address is the same as an IP address that I know is dedicated to the customer, then I must be in that location, and therefore the return statement is the virtual IP address. I could also do something where I say, let's do a DNS resolution, in this case, adfs.welshgeek.net. And I can say, if that resolves to a certain IP address, then I must be on the network, and this is the service edge that I should use. Otherwise, I must be on the internet, and I will use the public service edge completed by $gateway, $gateway host, $secondary gateway host, or $secondary gateway. So we can use these variables. We build a pack file that makes policy decisions to which nodes to use, either the public service edges or by private service edges, where I am in control of those IP addresses for those virtual IPs.